thank you everyone for coming to our talk. We're excited to share a little bit about what we built with a SQL AI bot using MetricFlows and LLMs. Okay.
Hi, I'm Kelly Wolinetz. I'm a senior data engineer. I've been at M1 for about 3.5 years.
I'm Brady Dauzat. I'm a machine learning engineer, and I've been at M1 for 3 years now. So just a little bit about what we're going to cover today. First, we're going to go through a bit about our business background and problem, so where we're coming from, the problem we were trying to solve with this project. Then I'll give a brief overview of the thing that we built using an LLM as an interface to dbt MetricFlow. Then I'm going to talk a little bit about why we didn't go with an approach about just using an LLM directly to write SQL for self-service analytics. Then I'll hand it over to Kelly, who is going to talk more in depth about the dbt architecture that we built and why that solves some of the issues that we saw with a different approach. And then we'll wrap up with some things that we learned in next steps for us. Okay, on to the business problem. So first, a bit about who we are. So we work for M1, as we said. M1 is the finance super app. So we're a medium-sized fintech company. We have millions of users on the platform, billions of dollars in AUM. We offer several products that let you do things like invest. We have a credit card product, cash accounts, all that kind of stuff, all just sort of geared towards helping users to build their long-term wealth. As you can imagine, being a fintech, this kind of data is very central to our business and operations. So here's a little diagram about the data infrastructure that we use on the data team. So we use Airflow for orchestration and ingestion of data into our Amazon Redshift data warehouse. On top of that, we have dbt, obviously, for transformations. And then we use Superset as our sort of self-service analytic tool for our business stakeholders. This tool, if you're not familiar with it, it has an IDE, so you can query the warehouse directly. It also has, functionality for creating charts, dashboards, all that kind of stuff for our business users. So even though we have this whole setup and a nice self-service tool for business users that we would love them to use as much as possible, in reality we found there's lots of barriers for our business stakeholders to actually take advantage of this self-service tool. This is for a couple of reasons. So one, data warehouses are very big and complex. I'm sure that's true for many of you out there. We have thousands of tables, tens of thousands of columns, just a lot of data spread out there. The other thing is that business users don't necessarily all feel very comfortable with their SQL skills or their data skills. They may not feel very comfortable pulling the data themselves, aggregating it in different ways, things like that. And then also, working in the finance space, there's lots of use cases where we have pretty high regulatory requirements that we're conscious of, and we need to make sure that whatever data is being pulled for decision-making or reports is indeed the correct data that we want to use. So what this ends up resulting in is that data users don't necessarily feel that they have the power to pull the data that they need to do their job, and they end up asking the data team instead to help them do it or do it for them. The problem with this, obviously, is that this then forms a bottleneck around the data team where instead of enabling the business to make data-driven decisions, we are actually slowing them down because they feel that they need to wait for us to help them do their jobs. Obviously, this is not what we want. We would like to unlock self-service analytics. So this is how we were approaching the product, is how can we make something that's going to help our business stakeholders actually be able to query the data warehouse themselves. Okay, so here is a bit about what we actually built. So this is just a diagram giving a really high-level overview of how the tool works. So I'll first describe it just like from the business stakeholder perspective. You're a business stakeholder, you write a natural language question into some interface, and you get a SQL query in response. You can then take that query, go plug it into Superset, and get the data that you need, create a chart, whatever it is you're trying to do. Under the hood, what we're actually doing is we're using an LLM to take that user's natural language question. Then we also give that LLM information about how to write a dbt MetricFlow command. And we ask the LLM to take the question, take that information, write a MetricFlow command that would answer the question. We then run that, get a query, and then that's what's returned to the user. So here is just a quick video showing like how the process works. This is Streamlit, which is what we use as our interface available within our company. And here's user question asking about getting a query to sum up invest AUM. And you just type it in there and you get a query in response. And like I said, you can just take this query and go run it. OK, yeah, so that's a bit about what we built. You might be looking at that and wondering, why do we have this extra step of going through dbt MetricFlow? Why don't you just have the LLM sort of directly write the query itself? LLMs can write SQL. They do understand it. So why are we going through this step? So that approach of having an LLM directly return the SQL itself was actually our first approach that we took in this project. This was for a proof of concept we did during a hackathon earlier this year. So the main thing I want to call out here is that the difference between this architecture and the one I just showed really is that instead of giving an LLM information on how to write a MetricFlow command and a user's natural language question, instead we gave it the question and we gave it information about our data catalog, which came from the dbt data catalog, so like schema, column names, descriptions, all that stuff, and then asked the LLM to take that information along with the question and write a query that answers the question. And so, this did have some success. Like we were able to get some queries that worked, but we found as we were, kind of playing around with this approach that we were running into some issues, particularly around hallucination. So it would hallucinate in some ways that you might expect. Like it would sometimes like make up a column name that sounded like the exact column that had the answer to the question, but the column didn't exist. It would sometimes, have syntax errors, stuff like that. But what I think is kind of more interesting to talk about is it would often hallucinate in ways where it would produce a query that actually worked in terms of like this query can run in our warehouse and would return data. But the data that it returned was not actually answering the question correctly. And in many ways, unless you understood the SQL that it was actually running, you wouldn't know that you're getting the wrong data to answer your question. So kind of given what we discussed earlier about the motivation for this project, this is, I think, particularly problematic because we don't want to be giving business stakeholders the wrong data with really no way for us to know that something is going wrong. So to, I guess, make it a little more concrete exactly what I'm talking about, I'll just walk through an example of what this looks like in terms of this sort of direct LLM writing a SQL architecture with this example. So here's a question a stakeholder might have that they want to get a query for. They're asking to sum up invest AUM by user for users with acquisition dates after January 1st, 2023. So invest AUM, if you're not in the fintech space, that's just assets under management. So that's like the amount of money a user has in our invest product on the platform. And then here they're asking it for users who were acquired after a certain date. So maybe a cohort analysis or something like that, looking at a product launch, whatever. So this is the query on the left that is returned from this sort of direct LLM writing SQL architecture that I mentioned. And as I said, like this query looks fine. This query will run. It will give you a column that says user ID. It'll give you a column that says total invest AUM. But if you look a little bit closer, it's not actually answering the question that was asked. So kind of the first and most obvious issue is that this query would return invest AUM for all users, not just users acquired after the date that was asked for. And the reason for that is that this query is trying to subset with this where clause here on generated date, not acquisition date. So obviously generated date and acquisition date sound kind of similar, but they're very different concepts, and you'll get very different answers depending on which one you use. And in this case, one of them is clearly incorrect given the question that was asked. What's also kind of interesting about this that kind of shows, I think, some of the larger problems with asking LLMs to do this kind of task is that you can kind of tell that the LLM, which makes sense if you understand how LLMs work, but it doesn't understand how to use these tables, and it doesn't really understand what it's doing when it's doing these joins and groupings. So what I mean by that is it's using these latest user metrics tables. These tables are already subset to the latest date. So in addition to using the wrong column, generated date here, to subset in the where clause, this where clause is also not doing anything because these tables are already only the latest data available. Similarly, the latest user metrics table here is already grouped at the user level and already contains the invest AUM field that is needed. So the join and then the group by also doesn't really make sense if you know what the latest user metrics table is. And so this is actually a pretty simple example, but I think it's a nice one to illustrate some of the problems that you can run into here. So I guess just to take a step back and think about, for us, why do we think we're seeing this sort of behavior from the LLM? Why are we running into these kinds of issues? Even though we are giving it the data catalog, which should, in theory, be explaining, what these tables are, what the columns are, all that kind of stuff. And I think what's kind of helped us think through it is this hypothetical question we have here, which is if you gave a smart person your full data catalog who had never seen it before, and you asked them to produce a valid query for key business metrics, would you trust them to do it? We're essentially asking the LLM to produce a query that accurately answers a business question and it needs to take into account all the kind of context around the business question, all the context of your data warehouse, the nuances of your data warehouse. And that's a very complicated task, one. And it's a task that also requires that we give the LLM all this context that it needs to be able to sort through that and answer the question. And what we were finding as we were working through this project is that that's actually very difficult to do for the entire data warehouse and to make sure all your bases are covered. And it's very difficult to do through natural language by just trying to add it into column descriptions or things like that. That didn't seem to work very well. So from this, this kind of seeing these issues with this approach is what kind of pushed us to look for a different method. And I'll hand it over to Kelly now, who will talk more about what it is that we actually built and how that works.
Great, thanks, Brady. So let's get into what we actually built and how we built it. So as Brady mentioned before, we are now going to ask the LLM to actually write a MetricFlow command. So yay, dbt, MetricFlow. So basically, MetricFlow provides us with two key features to solve this hallucination problem. One, it's a simple framework with which to define our metrics in YAML, and who here doesn't love writing things in YAML. And then second, it's a layer to ensure that what the LLM produced is valid in our warehouse. Essentially, it's operating as an interface between the raw LLM output and the user. So just a quick aside, you may notice that we're talking a lot about MetricFlow in the command line. We use dbt core. We have never actually used dbt cloud, so I hope cloud users, you might be able to draw some inspiration from this project and maybe apply it to how you're using dbt semantic layer. Okay, so we like to call this the Mad Libs approach. We did not coin this term. It was actually coined by Ben Stansel, who I think is speaking today. I saw him walking around. He wrote a Substack article that is linked down at the bottom there, titled LLM Shouldn't Write SQL. It's actually quite a good article. I encourage you all to look it up. But essentially what this means is taking our kind of thesis statement from earlier, if you gave a smart person your full data catalog who had never seen it before and asked them to produce a valid query for key business metrics, would you trust them? Becomes, if you gave a smart person a list of key business metrics in a fill-in-the-blank template for how to answer your question, would you trust them to do it correctly? And my trust would go way up. So now the smart person, aka our LLM, really only needs to know how to input a MetricFlow commands for the metrics and dimensions that are asked for in the user's question. Okay, let's look at how we actually did this. So to get this MetricFlow command, we are providing the LLM with two components. One is the system prompt, and then second is the user question. Here is the full flow of data, and I'm going to just break down some of these pieces. So first is the system prompt. It comes down to two parts, and the first one is this MetricFlow command directions. We talked a lot about how our goal is to have the LLM create a MetricFlow command. So now we need to actually teach it what a MetricFlow command is and like how to build it. Basically give it those fill in the blank directions. Now, if you were given a new command line tool just as a human, how would you learn to write any command in with that tool? Well, you'd probably Google it, number one. But second, there's help options. Most command line tools have just a help command. And that's exactly what we did. We wrote MetricFlow query -- help, and we were able to get all the options for this, for the command line tool. We're essentially going to copy this, and this is going to become part of our system prompt, just to, again, teach the LLM how to write a MetricFlow command. All right, so this is just one component of that. We also need to go through and actually kind of explain a little bit more about what MetricFlow, give it some more context, what we need it to do. So first things first, give it that fill in the blank template. That's the whole goal. Here you can see we want it to write MetricFlow query, where we want it to put the metric name, if there's a group by, where to put the dimension name, all that stuff. The next component of this is just explaining what entities and dimensions are. Another part that's actually not written here is also explaining what time dimensions are, because they are treated a little differently in the MetricFlow command line directions. Just with like different date filters, we have to provide that context so it knows how to do it correctly. And then also, we really wanted to emphasize this, to always add explain to the end of this command. Now, our whole project is having it produce SQL for us, and with the MetricFlow command line, if you add explain, it will produce the SQL for what you're asking it for. If you leave this off, it will try to hit our database directly and return data, which is totally valid. Like, that's actually a pretty good project. But that's not what we're trying to build. We want it to return SQL, so always add explain. And then finally, sometimes it's good to bribe your LLMs. Who knows if this actually works? We like to think it does, so it's kind of fun. Okay, so now the system prompt kind of knows what a MetricFlow command is. Okay, next we have to actually explain things about our database. We need to give it those metrics and dimensions. You might be reading this, DBT semantic manifest in XML format. You're like, hey, aren't you guys a fintech that uses the latest technologies? Yes, we are. XML is not that out of date, but we actually initially made this project in Claude 3, which I think probably some of these problems have been resolved in 3.5, but here we are. We found that it understood XML really well and JSON less well, so we just went forward with it. And essentially to get our database warehouse, give it all the information in this XML format, we designed a script to process the semantic manifest, which is just created in the background of your DBT project, to extract the relevant information about our warehouse and just put it into a nice XML format that we then append to our system prompt. Side note, there's just been so much talk about AI and how useful it is. This second bullet point, I actually just gave I think, no, not ChatGPT, Claude, the script that runs all of this, and asked it to summarize it, and that is that second data point, so it's kind of fun. Okay, all right, here's the XML, very scary. Here's just a small snippet of what this actually looks like. Again, we're going through every single metric that we have defined, and we are able to just extract this from our semantic model definitions, our metric definitions, and we're going through and getting all of the dimensions You might ask, how do you do that? Well, of course, we use another MetricFlow command. You're able to get a list of all the dimensions for each metric through this command that you see at the top. And so we're getting all the dimensions, plugging that into our XML, along with descriptions, any relevant information, again, to help the LLM. And that, again, just comes from the semantic model itself. OK, so that's a system prompt. Now it has all the information about our database and how to actually make a MetricFlow command. Second is the user question. This is the easy part. We don't have to write this. The user writes this. So this is just a zoomed in bit of what Brady showed you earlier in that video. This is just the chatbot interface that the user will see. And again, it's that same question that we talked about earlier, sum up and best AUM by users with acquisition dates after January 2023. OK, all that stuff goes into Claude, and a MetricFlow command is produced. So from a user perspective, they will not see this, but of course we can debug things and see the MetricFlow command that was produced. And here it did it. We have our fill in the blank. It filled in the blank correctly. We have our metric there. It's even using the time dimension correctly. So yay, I described that accurately in the prompt. And we even have our explain. So I think the bribe worked. All right, so the command is run in the background, and that will actually produce the SQL. And then that is what is returned to the user. So what the user actually experiences, here I have this little GIF. I know it's blurry, but you get the idea, okay? We've all used chatbots before. So the user will see an easy-to-use chatbot interface. It will produce a copyable, correct, and nicely formatted SQL query. And then the user can plug this into Superset or whatever SQL ID they're using to get their analytics answer. One thing I want to call out is we have a lot of SQL users at our company that maybe just don't feel confident like getting that first query set up. So that's where we get a lot of our questions that Brady showed earlier in Slack. So there's just a really good solution to get people kind of just that first step, teach a man to fish, as they say. And then from here, they can maybe filter on different dates or add different dimensions and all of that stuff. All right, so let's wrap some things up. First things first is the impact. So we have held information sessions for our engineering and non-engineering teams, which is really encouraging. It's non-technical people using this product. We don't have extensive data usage, but we have just received positive feedback, and people are using it, which is great. We love it when people use our tools. We have users reaching out for requests for new metrics. One thing about this, obviously, is you have to have the metrics defined if you want people, oh my gosh, you need to have the metrics defined if it's going to return them as an option. So that's something we need to continuously build out. And then just anecdotally, we have seen a decrease in our Slack requests, which the data team loves. All right, so what we also learned about this DBT-based, Mad Libs approach, again, it requires all the metrics to be defined by DBT users. This can be a bit daunting. Thankfully, we were using DBT metrics before MetricFlow, so we had a lot of things defined. And you know what? Honestly, we probably could use AI to define some other ones. So we'll get over that hill. And then second is generating the system prompt requires a lot of overhead. I'm sure you guys are all looking at that and saying, you list every single metric and then you have to find all the dimensions. Yeah, it takes a long time. Definitely can improve that. However, it's part of the deployment process, so it really just happens once and then it's ready to go. So some upsides, obviously, hallucinations are basically, there almost are none, for the end user. Also just completely eliminated SQL syntax errors because we can kind of, we're ensured that what MetricFlow is going to return is valid SQL for our database. Essentially, the solution that makes sense for you, whether you want to use, the RAG approach of loading your whole data catalog, or if you want to maybe do this Mad Libs approach, really just depends on how you weigh these pros and cons. All right, so finally, next steps. Again, third time, adding more metrics. There are always more metrics to add. People are always coming up with new metrics. So that is the number one thing. Second is to integrate with Superset. Superset, awesome open source tool. It would be awesome if this was an actual chatbot in our window so people don't have to go back and forth. And then also experiment with different error handling approaches. This is just something that can always be improved just in life. And then finally, restructure the chatbot to also answer general questions about the warehouse. It would be great if the user could ask what dimensions are available for certain metrics, or maybe just general catalog questions or schema questions, just all in this one chatbot. So great, thank you so much. We appreciate you all coming, and yeah, that's it. If y'all have, oh yeah, all right, great. I was like, you guys can come up and we can chat, but no, let's do it.
Thank you so much.
Thank you.
My question is, do you have any concerns about blowing up compute costs once you export this to everyone?
Not.
Compute costs in terms
Could
of...
you repeat that question?
Oh,
Or I can handle
yeah.
it.
He asked about if we had concerns about blowing up compute costs when we deploy this. Oh yeah, are you asking about?
Is there like cost for LLM or?
Able to run queries made probably on the huge data sets, all the business people.
Oh,
Honestly,
Not really?
not really. Maybe we should have considered it. Honestly, we haven't run into problems.
You have deep pockets probably.
Yeah, we haven't run into problems. Also, our company's not that big, so I'm sure it could be an issue.
and also giving them the right query that they run once is better than them trying to run 30 different queries over and over to get the right answer. So
That's a great point. Yeah.
So you talked about XML and JSON, but the initial definition of the metrics are in YAML, isn't it? So why didn't you put the YAML directly in the? Why didn't you use the YAML directly? I didn't get why there was this translation in XML done.
Yeah.
What it brings to.
Yeah. So we ran into some issues just for the fact that it wasn't quite easy to extract all the valid dimensions for each metric, and we wanted it to kind of all be organized in that manner so the LLM could just easily understand that. Not that it's understanding things, but you get what I mean.
yeah, the Anthropic models, I'm not sure why, but they were trained to recognize and understand XML specifically. So it just worked better if we gave it XML, since that's how those models were trained.
Yeah, and you might have seen that it's like user ID _ dimension name. So that is a MetricFlow syntax. I'm not going to get too much into that, but it's basically using like a user ID is kind of the join key that it's intended to use. And you can imagine this really blows up with all the dimensions that are available once you have many models defined. So going through that process of listing all the dimensions and then getting that into the XML, that's really what we had to do. So, oh yeah, I mean, there's a few, so.
I can run.
Have you done any model evaluation of the LLM layer itself? So I noticed the way that you wrote that query, into the Streamlit chatbot, it looked like a query that one of us would write. So it's very sort of like almost SQL-like. We know the sort of words. We use group by and stuff like that in natural language. But many business people don't write their natural language queries like that. So is this currently giving you 100% accuracy in terms of what the users are looking for, or have you still yet to do that evaluation stage?
To be honest, we haven't done too much analysis of that, so I can't really speak to that. But like I said, we have a lot of just data literate people, and if they're going to be using this tool, there is kind of a basic understanding of how SQL works. So, and I don't know if you saw also in the Streamlit app, there we provide some like descriptions of, hey, maybe you should ask for these metrics and these dimensions, things like that, and just examples.
Yeah, so we do tell them like what they can ask for, and what we've generally seen like when there are issues, what happens is they ask for something that's not there, and because we have the layer of we need to run this MetricFlow command first before anything's returned to the user, just an error is just returned to them, so it's not going to be any sort of like SQL that they'd accidentally run. It would just say, I mean, this is where we could do better error handling. Like we could tell them why they're getting an error, like what they should do different, but yeah.
Okay, we have time for one more question, and then if y'all have time, I encourage folks to come up and ask you.
Yeah, so you talk about a little bit about the next steps, about experimenting with error handling. I wonder, like, what you experience with the agent base, like, you know, the LLM kind of self-checking, like, its outputs. Like, what's your experience with that, like, maybe for this question and for this problem and in general?
Yeah, that's one of the things we're thinking of with error handling. So we could, if there, something was wrong, the MetricFlow command didn't work, we could feed the error from the MetricFlow command back into the LLM along with its original input and say, like, can you fix this? I think that's something we'd like to do. I'm not sure it's, that could get costly depending on how many times that runs, and I think like the lift and benefit of that for a tool that's just sort of like internal, where we know a lot of people that are using it and can resolve errors in other ways. Maybe it's not like extremely pressing, but yeah, that is something that I think would work and we would like to do.
Great, thank you.